concept we want to look at. Some people call it triangle law of vector, some just call it addition law of vector. Yeah, it doesn't matter, the idea is what we really need to understand. And this we use in vector addition. When we talk about vector addition, we are not restricting the addition to plus. Subtraction is an inverse addition itself. I would expect you to pay attention right now before you get lost at the point. So now this is what it looks like. Now, picture it in a more realistic form this way. This is SON. This is the park. What do we call it? Central Park. Okay. So Central Park. Maybe I use C for that. Where can we go from Central Park? We can go to $10 shop. So this is $10 shop. Okay. This is about you getting to destinations. It doesn't matter where, it's not like saying long. We're not talking about the length now. But definitely the length will be different. The length is the magnitude. So, if I'm trying to get to $10 shop from SOA, I could decide to go to Central Park and then go straight from there. Or I could just go straight down this road. Where is that? I hope I'm not facing the wrong direction. Oh, okay, so I'm just going to be, okay, this road. Okay, I could go straight from the road along the post office. You know what I mean? And get to $10 shop. Or I could go here, go to Nova Park. Nova, what is that building?
Central.
No. What is that Nova? Yes, Nova Park. Nova Park is the one in front of Central Park, right? Come on, I know the place. Alright, so I could start from my journey from SON. Maybe I need to say hello to someone on the way and go through the Central Park to Nova Park. Okay, then come straight to $10 shop. Or someone else could decide to go from SON. So basically what this is saying is that going from here to here and going from here to here, and is the reason for the plus, achieves the same thing if you go straight. Does it make sense? Yes. Again, going from SON to Central Park, then going to this place, that is your A plus B, is the same as going straight. So this is C. We are saying that C is the sum of A plus B. Look at that direction. The direction is very important. So if a vector is like this, and you want to form a parallelogram or triangle or vector, so this, in fact, even if this is the question, you can go like this first. So you will claim that, oh, rather than go straight this way, I may decide to check a friend here, then go through this way. So if this is P and this is Q, someone could ask you to find the vector R. You will notice there's no way they could join. Look at it. If you want to combine this and this, you need to have this, right? If I want to combine P and Q, I need to have this one. No, I need to have this one. Do you agree? Again, this is my starting point. I start with P, then I go to Q. This is my destination. Then the direct way should be this way, isn't it? So which means that is the negative R. So my negative R is actually P plus Q, which means my positive R will be negative P, negative Q. So that's how we use the triangle law. Okay? So let's see it in the XY plane. Then you can appreciate what I'm trying to say. That's why I've used this Central Park issue to make it clearer to us. Now let's use the XY plane and see. Let's write the vector that represents P. Can we write the vector that represents P? From here to here, what is that vector? What's I plus what's J? 3I. I need everybody's contribution now. Plus 8, 7, which one? 8J. It means from P to Q, you move horizontally. How many units? 3 units. Remember, you move from 1 to 4. This is 1. P is here. And the other part is here. So you have moved 3 units forward. Right? Yes. And vertically, you have moved from -3 to 8. That's 8 units of movement. Does it make sense? Now let's look at vector Q. Vector Q. How many I and how many J? 3i, yes, negative 3j. So from 4 to 7, you move 3 units forward, right? But from 5 to 2, you move 3 units downward. That's why it is negative. Does it make sense? Now let's see the vector represented by r. So r is from here. So how many? 6i, that's from 1 to 7. Then how many j?
5.
Plus 5j. Now isn't this the sum of these two?
Yes. Oh.
So that's what we mean by the triangular vector. So if someone decides to go from here to check on Justin in his apartment, then go to the roundabout, maybe there's a nice restaurant there, and the rest of us decide not to go to Justin's place and we just go straight to the restaurant, we all achieve our aim. We're not talking about the length. Because definitely the length of P plus length of Q will not be the length of R. Okay? We're talking about achieving the objective in terms of getting to the destination. What path can you take? See that as a path you can take. Does it make sense? So again, the arrow is very important. The arrow is very important. If this is my starting point, and this is my destination, okay? The shorter one comes first, which is the one that goes directly comes first. Then the rest is the one you had together. Okay? Try to find your starting point and your ending point. The direct one is the first vector you consider. Then the other one that you have to go two places are the ones you add. And it's possible some of them come with minors. We're going to see that in one of the questions. So let me look at one of the questions. So everybody go to question 1. Let's look at question 1 as ratio. I don't want us to do ratio thing first. Let's look at something that has nothing to do with ratio first. So that was ratio. Okay. Okay, we can look at question, let's see, yes. I didn't say PS, I mean PS. Maybe we just deal with the ratio one because almost all of them have ratio. Okay, let's look at question 1, everybody. I didn't write the years of exam, but they're all like IGCSE. I'm sure when you're trying to solve your past paper, you come across them again. Okay, question 1 goes thus. I'm just going to put the shape here. So we will write every other thing. Just we need to extend something. RQ is extended, OT is extended. Okay, so we need more space. So how about put it here? Looks like a rectangle, but of course, diagrams are not drawn to scale, so do not assume it's a rectangle until you are told to do so. So T is somewhere here, Q is here, R, M is here, P is here, Q is here. These two are joined. Okay, that's what we have. I need everyone's attention. So the first question, you want to share with someone, or you can keep this and you can share with someone. Okay, so the first thing is, this is O actually, not Q. So O, P, Q, R is a rectangle, so fine, it's a rectangle, they told us. O is the origin. Okay, so it's like this XY plane where O is the origin. That's nice. M is the midpoint of RQ. M is the midpoint of RQ. Okay, good to know. If that is the midpoint, there's an arrow, there's no arrow. If that is the midpoint, then if it goes in this direction, this is half P. Okay? And this is also half P. in this direction. If the direction is this way, what's the problem? If I'm not ready to learn, can you not talk to anybody? If the direction is this way, it's going to be negative RQ. Remember what I said earlier. The direction of, if they have the same length, direction is just negative of the other one. Okay? So I put this because it wasn't indicated. So I put the direction myself and wrote that. Okay? Now, T, so we know that PT ratio TQ is 2 to 1. What does that mean? So what is this place? PT, where's PT? PT, so that means we're talking about this direction. So what will be the vector represented by PT? R over what? 2R over 3. Where does that come from? Why not just maybe 1 over 2R or something? What does this ratio mean? I'm not saying she's wrong.
Because there's 3 points in total.
It says there are 3 points in total from P to T. So we have from here to here divided into 3. PT takes 2 and this takes 1. So total ratio is 3. Alright? So the first one is 2/3 and the second one is 1/3. That's what it means. Does it make sense? And if everything is R, it means this is what? 2 over 3R and this is 1 over 3R. Okay? That's why you were told that the ratio is 2 to 1. So when for every 2, there is a 1. It means you always have units of 3 all the time. So once you start getting all this, you need to label the part that were not labeled. And that's how it can become clearer to you. So the first question, A1, is to find MQ. That is from M to Q in that direction, direction M to Q. Okay? So MQ is from here to here. I think that's easy. We already found that in our analysis. So that's 1 over 2P. Okay? The second question is to find MT in that direction, from M to T, from here to here. So what do we know? So if instead of going from M to T, we can go out.
1 over 2p.
Please listen to my question and answer only what I ask, please, so you don't confuse the rest. I know you know it, but that's not what I want to hear. Instead of going from M to T, we can go out.
M to Q.
M to Q. I just write to T.
Q.
Plus Q to T. Does it make sense?
Yes.
So instead of going from here, we can go this way then come this way.
Yes.
That's why I was using Nova Park and all those stuff. So it's easy to visualize. So then you look at it. Do you have your MQ? Okay? Don't forget that the arrow goes this way as well. If the arrow comes the other way, then that's not what you want to do. What about QT? From Q to T, is it the same as 1 over 3R? No, because this arrow goes this way now. Now if you are coming backward, what is that? Negative 1 over 3R.
Which way is it?
No, look at it. We use this because this goes this way.
Yeah.
R goes this way. So that's why this is also R. So now you are coming back from M to T. So it's not going to be 1 over 3R, but the negation of 1 over 3R. What? Here. I'm comparing with this R. Okay, I'm comparing, because it's a rectangle. So these are parallel.
Do they have to be, or can one be on the opposite way?
But we just changed it. They don't have to be. But in our own initial analysis and understanding, if this is R, then this should be R. Does it make sense? Any questions? Okay, so let's move on. OT. OT. From O to T, what do we have? That's from here to here. So, what can we do? Instead of going from O to T, how can I move? O to P plus. Now, this is known to be P. Is PT the same direction with this?
Yes.
Yes. So that's 2 over 3R. Okay? So it's not difficult. You just have to Take your time, understand the principle, and the rest is, that's why I call it vector algebra. Alright? So, the last part, it says, actually question B, but you've done the last part already in the first one. It says, RQ, now pay attention, RQ, this, and OT are extended and they meet at U. So I can assume also that this comes like that, right? And of course I found OT, so I can assume this. So if I need otherwise, I change it, doesn't matter anyway. So the question is, find the position vector of U. Position vector is always with respect to the origin. So the position vector of, if this is A, the position vector of A is OA. Okay, it's always with respect to the origin. So basically they're asking you to find OU, not him.
OU.
That's him. Alright, so basically position vector is you describe it with respect to the origin. So position vector of U, that's B. Okay, so now how do we do that? Do we know we don't know the distance, do we?
Do you have 5?
Okay. Any additional information about, we just do this extent.
Daniel?
We have this, yes? Have a question?
Can you just use like a Pythagoras theorem for this?
Pythagoras what? It's not length.
Oh yeah.
You can't use your length unless you have, you can't use Pythagoras unless you have your length.
Actually, I want to go to the bathroom.
Anything else? We have this, we have that.
Did you miss something?
Maybe. I might have. Because we're supposed to know how many ratio we have in the extension.
Go to the bathroom.
Oh yes, you can go. We need how many ratio we have in the division. Yeah, I think I must have missed something there. I must have missed something there. So listen, I'll try to find that ratio. There must have been a ratio, maybe a ratio RQ to something is this. After the extension, I think there must have been an additional information that I missed out. So with that ratio, you can get what this is, and you can get what this is, then it will be easier to get your OU. I'll find it before we leave the class. Okay, I just need to look through the past papers. Does this make sense?
Yes.
So let's attempt. Can I ask you to attempt question 6? That looks quite easy, I think. Attempt question 6. Attempt question 8. Okay, just take those two first while I look for those questions. Joey, can you pause that since we're not longer explaining something? Can you pause it, Cecilia? That's the right button. Make sure this is covered first.